In physics, power is all about the rate at which energy is transferred or transformed, and you'll have seen from one of the previous videos how you describe those two processes and why they're different. So, power. How do we measure it? The unit of power is the watt, named after James Watt, and 1 watt equals 1 joule of energy per second. So if we wanted to work out the amount of energy that had been transferred or transformed, for example, we'd use this equation. Amount of energy in joules equals power in watts multiplied by the time in seconds. So for example, when you look at a light bulb, you'll see that it's rated as perhaps a 100 watt bulb. What that means is that every second 100 joules of energy are being transferred by the bulb, or being transformed by the bulb. So what's that got to do with efficiency and stuff like that? Well, this is what. If we take that example of a light bulb again, because it crops up quite a lot. A light bulb, even if it's as badly drawn as this one, is basically a device for turning electrical energy into heat and light. And quite simply, it's really good at turning electricity into heat and not so good at turning it into light. If we were to take 100 joules of energy from the electrical supply, about 90 joules would be turned into heat, and only about 10 joules would be turned into light. So we can use these sorts of equations to see just how quickly, or indeed how efficiently, the energy is being transferred or transformed. In the case of an ordinary light bulb, it's really inefficient. Here's why. Efficiency equals useful energy out divided by total energy in, and then you multiply the whole thing by 100 over 1 to turn it into a percentage. So our light bulb, for example, useful energy out 10 joules, that's light. Total energy in 100 joules of electrical energy. Well, multiply that by 100 over 1 and you get 10%. So we can use this equation to work out the efficiency of a device, and we can use this equation to work out how quickly it's transferring energy.